Good day, sir. I am Maria Clarice Sabilino, and I will be presenting my software application called PawScan. Before I go further, my application is all about different kind of dog breeds and image classification, but I only choose 10 specific breeds for the project performance. So now I'm going to show you my application. So here is my application system. I did apply an aesthetic design with soft green theme color to reflect a pet-friendly incoming user experience. When this button is clicked, the application navigates to the history page where the 10 classification classes are displayed for user reference. If we click one specific breed, we could see the description, and it also has a carousel effect and also the stats of the breed, and it has a button where it navigates to classify an image. Now we are on the camera page where the 10 classes are displayed, and also we have analytics of the results. If we click one specific breed, just like in the history page, it will navigate to the classifying image. So now we're gonna start classifying a breed. First, we have Airedale, a loyal terrier. As for the project requirements, we're gonna use camera for classifying the image. So as you can see in the screen, we have an Airedale picture. So we're gonna try to classify it. So the result for the image shown on the screen, this is an Airedale, it's a pug, with a 0% confidence and accuracy. Although we didn't get a confidence and accuracy rate, we still have 2 times to try it again. So for the second try, unfortunately we still didn't get the confidence and accuracy rate for the image shown, which is the Airedale. Next we have Beagle. We try classifying the Beagle. So for our first try, the confidence and accuracy rate is actually higher. The confidence is about 80.5% and accuracy is 90.5%. So the classifier identifies that this image is actually a beagle. So next breed is the Bernese Mountain Dog. So let's classify it. The results is actually low. This isn't a Bernese, it's a Chow Chow. So the classifier thought that the image is a Chow Chow. So for the second try, we actually get a little bit higher for the confidence. For now we get a confidence of 30.5% and accuracy is 50.4%. So it's higher than the 0.1% for the confidence earlier. So next up, we're gonna try to classify Cairn Terrier. So for our first try, we actually get that the image itself is a Cairn Terrier. This is a Cairn Terrier. So the confidence is 100% and the accuracy is 80.5%. For the next, we have Chow Chow. We're gonna try to classify it. So for our first try, we actually get the result, and the result is this is a Chow Chow, and the confidence itself and accuracy is 100%. So now next up we have the Ently Butcher. We're gonna try to classify it. So for our first attempt, the result is this isn't an Ently Butcher, it's a pug. So the classifier thought that the image is a pug. The confidence is 0% and also the accuracy is 0%. So let's try again for the second attempt. For the second attempt, the confidence and accuracy itself is getting higher. The confidence is 50.5% and also the accuracy is 65%. So yeah. So next up we have Maltese. Maltese is a white-coated dog. I also have a Maltese. They are very loyal, really cute. So we're gonna try to classify it if we get 100% of confidence and accuracy. So wow, for our first try, the classifier identifies that this is a Maltese we get the confidence and accuracy rate of 100%. So we're gonna try it again if it still has that result. So for the second attempt, we actually still get 100% of confidence and accuracy. It's about this. So for the next breed, we have Pug. Pug is actually cute. So we're gonna try to classify it. For the first attempt, we actually get confidence of 30.5% and also the accuracy of 50.5%. This is a pug. Yes, the classifier identifies it as a pug, but the problem is the confidence is lower than the accuracy. So for the second attempt, we finally get a confidence rate and accuracy rate of a 90%. For the accuracy and the confidence is 100% rather. So this is a pug. So the classifier identifies that the image itself is actually a pug. So for the next breed, we have Silky Terrier. So let's try to classify it. So for the first attempt, the result, unfortunately, we didn't get 100% of confidence and accuracy. It's lower than that. This isn't Silky Terrier, it's a Cairn Terrier. So we're gonna try for the second attempt. For the second attempt, it's still, we didn't get 100% of confidence and accuracy. We still get lower than that. So next breed, we have Tibetan Terrier. It's a big dog. Tibetan Terrier can also identify as a Maltese or even a Chow Chow itself because of its fur and also the cuteness. So we're gonna try to classify it if it's a Tibetan or not. So for our first try, we actually get it's a Tibetan and the confidence and accuracy itself is 100%. So the classifier identifies that this is a Tibetan. Although some breeds we didn't get the 100% of their confidence and accuracy, I don't know why. I did test it before I started this video, but maybe because of the quality of the camera and also the lighting itself. But I will still try to classify those breeds to get the 100% confidence and also the accuracy. So the question, what Flutter state management approach did I use and why was it suitable for your project? I use Flutter's built-in set state with stateful widget because the app has a simple and linear structure. The main state page navigation, selected breed, and classification history is handled in main app state. Since the app has only 3 pages and localized state changes, advanced state management wasn't necessary. Data persistence is handled separately using shared preferences and Firebase Firestore, making this approach efficient and appropriate for the project scales. So the next question, how would your system handle an increase in the number of image classes or users in the future? Currently, the system supports 10 dog breeds, reflected in the TF Lite model and static breed list. To scale, I would replace the model with one trained on more breeds and move breed data to Firebase Firestore or an API for dynamic loading. For multiple users, I would implement Firebase authentication and link classification to user ID, enabling personalized history in Cloud Sync. The architecture would shift from local storage to a Firestore-centered user-isolated design, allowing scalability without major factoring. Actually, on my app, it actually had a Firebase sync, which where we could see about 3 buttons that has reconnect, sync, and also a close tab button. For the next question, what part of the project did you find most technically challenging and how did you overcome it? To be honest, the most challenging part of the project was TF Lite model inference and image preprocessing. I needed to ensure that the input image matched the model's training requirements by correctly converting image data and normalizing pixel values, since small errors cause inaccurate predictions. Although not all classification results are perfectly accurate, the model performs um, reliably within its current scope. I also address issues with confidence scores by applying calibration techniques to make results more understandable to users. Overall, this showed that machine learning deployment requires careful processing and validation, not just running the model. I think that's all for my project presentation for my PawScan application, different kind of dog breeds. If if you have time to visit my GitHub profile, you can click the link below. And yeah, that's all, and I thank you. Bye bye.